Right guys, matrix, you need to listen to the sigma notation. Very, very important. Consider the expression, watch this. Now don't run away, Look at this. Sigma, this is very weird. It's got a sort of a general term thing, and then it's got k equals 1 and 4. Now what on earth does this mean? This thing, well, sigma in Greek means sum. So it's got to do something to do with a series we're adding up. Okay. Now, but what does all this funny stuff here mean? I don't know about you. Let's have a look. Okay, we've got k equals 1. So it seems like we've got to put 1 into there. Okay. Well, don't panic. Let's see what this funny thing means. Okay, what do we do? Well, what I'm going to do is to get the series is we substitute the values. Now look at that, k equals 1, 2, 3, and we stop at 4. So you start at 1 and you go 2, 3, 4, and you get some k values, which we're going to substitute them into this expression there. Into that expression that. And then we're going to add them up. Okay, so you start at 1 and start at 4, and there you go. Okay, now let's see. And we then add the answers. Okay, so let's see. If you then put k equals 1 into there, you get 2 times 1 minus 1. Good. Plus, now we're going to go k equals 2, because remember we're going 1, 2, 3, 4. So we've substituted in 1. So let's substitute in 2. Okay, now what about this? Then there's 3 and 4. Okay, so we go from 1 to 4. Look at this, there's 1, 2, 3, 4 terms. And then if you simplify that, 2 minus 1 is 1, 4 minus 1 is 3, 6 minus 1 is 5, and 8 minus 1 is 7. Okay, adding that up will give you then 16. So very simply put, sigma notation, as they call it, this Greek symbol sigma, is really just a series. So you always start at the k equals 1, go up to 4, 1, 2, 3, 4, substitute in and add. Okay, just something to observe here quickly. When working with sigma notation, it is of utmost importance that you know how many terms you are adding. In the previous example, there were 4 terms. Okay, look at this. Now I want you to watch that. Well, let's see. Well, we're going to start at 1 and then go 2, 3, 4, 5 up to 6. Stop at 6 and plug into 2k. So what's that? 2 times 1, 2k. 2 times 1, 2 times 2, 3, 4, 5, and 6. And notice we get 1, 2, 3, 4, 5, 6 terms. There's 6 terms. Now, something very interesting about the number of terms. If you take the top, okay, which is 6, and you subtract the bottom there 1, that gives us 5, but there's actually 6 terms. So all I do is if I add 1 at the end, look at this. Top minus bottom plus 1 gives me 6 terms. Okay, very important little thing. Top minus bottom plus 1. Good observation. Let's have a look at another one. Let's say I started at k equals 0. Okay, so I go 0, 2k. Remember, you're substituting into there. 2, 0, 2, 1, 2, 3, 4, 5, and 6. Okay, what does that give us? 0, 2, 4, 6, 8, 10, 12. How many terms? 1, 2, 3, 4, 5, 6, 7. There's 7 terms, not the guy on top. Do you see that there? Many matrics get that muddled up. You've got to go top minus bottom plus 1. Check this out. There's 7 terms there. Okay, top 6 minus the bottom plus the 1. And you land up with a 7. 1, 2, 3, 4, 5, 6, 7. Very, very important. Okay, let's try another one. What if it was k equals 2? Well, we start now by going 2, 3, 4, 5, 6 into 2k. 2, 3, 4, 5, 6. Work it out. 4 plus 6 plus 8 plus 10 plus 12. There's 1, 2, 3, 4, 5 terms, not the 6. So how do we work this out, the number of terms? Okay, it's top 6 minus the bottom, add the 1, gives you 5. Very important. So clearly you can see that the last value you substitute is not necessarily the number of terms that should be added. Okay, so what's the rule? Number of terms is the top minus the bottom plus that. Okay, all right. Just let me pause it there. How many minutes, Chris? 5. Good. Okay, thanks. Just cut this out in the edit. Okay. I'm just going to move to cut out the content a bit. We've got too much content, so I'm just going to take it down to here. Okay, have a look here. All right, good. Okay, clearly, okay, let's go for it. Okay, I'm picking up from here. Let's continue. Right, guys, arithmetic and geometric series. Okay, and we're going to link it to sigma. Now, watch this. There's nothing difficult about this. Check this. If you've got to calculate the value of this, notice that the number of terms is not 100. We want to get a series and then add it up. Now, how do we do this? Have a look here. Well, what is the number of terms? Okay, if you think about it, okay, well, firstly, let's get the series. We're going to start at 4, substitute into there, and go up to 100. Now, that's interesting. So it's 2, that's 4, 5, 6. But now, we can't put them all in, so let's just put dots and go all the way up to 100. Okay, let's tidy it up. 8 minus 1 is 7. 10 minus 1 is 9. And 6 times 2 is 1. Minus 6, 12 minus 1 is 11. Up to 200 minus 1 is that. Now, again, what we need is the number of terms. We know the A is 7. We're adding 2. The D is 2. You're adding 2. So we don't have any problems here. We can then say the number of terms is the top minus the bottom plus 1, which is 97. 97 terms. It's arithmetic or linear. Okay, we're summing now, so it's the metric formula SN. So let's check. Okay, there's the first term. There's the constant difference. The last term is 199. And the number of terms, again, let me iterate, is top minus bottom plus 197. You see, people, very, very interesting mathematics. So when you see sigma, make it into a series. Start with the k equals whatever 5 or whatever sub in to the little thing on the right, little term, go up and stop at the top. But know your number of terms, that's very important. Okay, so there it is. The SN is n over 2a plus l. Okay, guys, now substituting 97 over 2, we get 991. Great stuff. Guys, great being with you. Stay with us for the next part of this lesson.